Welcome to Short-Term Decisions, Part 6. By the end of this ACLET, you should be able to use differential analysis to determine the optimal sales mix. This ACLET is a continuation of Short-Term Decisions, Part 5. When a business produces more than one product, it needs to determine the optimal sales mix, that is, how much of each product to produce in order to maximize contribution margin. This decision is complicated when we have a limited or constrained resource. This is a resource that we run out of first. Sometimes it's a machine needed to produce both products and we have a certain number of machine hours available. Sometimes it's direct labor. Skilled workers are needed for both products, but we can only find a certain number of skilled workers. Sometimes it's a direct material required for both products, but its supply is limited. In addition to the fact that we might have a limited resource, we will often have customer demand limitations. So after we decide which product maximizes our profits, then we have to factor in how many of each product we can actually sell. Because of these factors, this short-term decision has various names: sales mix, optimal sales mix, constrained resource, and limited resource. Regardless of the customer demand for our products, the first two steps are always the same. Step number 1, for each product, calculate the contribution margin per unit of product. Step number 2, for each product, calculate the contribution margin per unit of limited resource. We'll use a company called Aircrafts Inc. as our example. Aircrafts makes hoverboards and drones. The same machine is used to produce key parts for both products. Here is Aircraft's data. Pause the ACLET here so that you can read through the information. As always, the way you document your calculations might be different, and that's okay as long as your results are the same as ours. We'll start by identifying the two products that are in question, boards and drones. Our first task is to calculate the contribution margin per unit of product for boards and for drones. Since our data is already in per unit of product amounts, we can take the selling price minus the variable costs. Contribution margin per board is $66 and $144 per drone. If we had no limited resource and unlimited demand for our products, we'd make all drones based on these contribution margins. But we do have a limited resource, so we go on to step 2, calculate the contribution margin per unit of limited resource. Our limited resource is machine hours, so we need to know the contribution margin per machine hour for each product. From the data we were given, we know that we can produce 1.8 boards or 0.7 drones in one machine hour. For boards, we can multiply the $66 contribution margin per board by the 1.8 boards per hour to get contribution margin per hour of $118.80. Every hour that we use our machine to make boards, we are generating almost $119 of contribution margin. We'll follow the same process for drones. Multiply the $144 contribution margin per drone by the 0.7 drones per hour to get contribution margin per hour of $100.80. Which product, boards or drones, makes the best use of our limited machine hours? Boards. Now we know. If we assume that we can sell as many boards as we can make, how many boards can we make? We have 2,000 machine hours available, and we can make 1.8 boards per hour. 2,000 hours times 1.8 boards per hour is 3,600 boards. If we can sell 3,600 boards, then our optimal product mix is 3,600 boards and 0 drones. We'd use all of our limited machine hours to make our more profitable product. The more common scenario is that we have limited demand for our products. So now we will assume that we can only sell 1,200 boards and 1,000 drones. It's going to take us 3 steps to figure out our optimal sales mix. Doesn't it make sense that we would first figure out how many hours we'll use up making as many of our more profitable product as we can sell? How many hours will we use up making the 1,200 boards? Then we'll need to know how many hours are left over to use for making drones. And finally, we'll need to figure out how many drones we can make in the leftover hours. So, given the limited demand for boards and drones, we'll start with step A, calculate how many hours we'll use up to make 1,200 boards. We can make 1.8 boards each hour, so 1,200 boards divided by 1.8 boards per hour is 667 hours, rounded. Then step B, calculate how many hours are left over to make drones. We have a total of 2,000 machine hours available, so 2,000 hours minus 667 hours used for boards equals 1,333 hours left over for drones. And step C, calculate how many drones we can make in the 1,333 leftover hours. We can make 0.7 drones each hour, so 1,333 hours times 0.7 drones per hour is 933 drones. Considering our limited machine hours and the limited demand for our products, our optimal sales mix is 1,200 boards and 933 drones. This concludes the ACLET Short-Term Decisions, Part 6.